Okay, so let's do a quick little recap on zero and negative exponents. So page 4A. Aaron, what did you get? 1. That's right. B, Phil? Also 1. All right. Connor, C on page 4? -1. Good job, because notice there's no bracket around that -8, so your answer is -1. D, Aiden? 9/4. What did you do? Reverse subtraction, 30 to the power of 2. Excellent. Okay, and keep note of the format. When you flip that base, you took care of the negative exponent already. So when you write it, it's +2. So after you flip the base, it's +2 exponent. And then 3 times 3 is 9, 2 times 2 is 4. E, Simon? -125 over 8. -125 over 8. Good. Does it matter where that negative is? No, doesn't matter. You can put it on the top, on the bottom, on the side. As long as there's just one negative in the whole fraction, that number is negative. Fujesia F? Sorry? Okay, does the negative exponent make your answer negative? No, so it's 4/1, but you do flip it, so it becomes 1/4. That's right. Okay. Kingsley, G. 1/49. So remember to flip it and then square, so then 1/49. Shrenik, H. -1/8. Good. Okay. I, Grace? 0 square for I? 0 times 0? 0, right. Alright, so 0 square is just 0. So you weren't here, so Ryan, J. Undefined, that's good. Okay, because 0 to the -2 means 1/0 to the exponent 2. Can you put 1% in 0 group? No, so it's undefined. On the test, if you write air, it's not wrong, but it just sounds so less mathematical. Okay, so undefined. Sounds much more professional, doesn't it? All right, K, Joanna. 25/4, perfect. Okay, and then last one, Edward. 1/216. Awesome. All right, so out of these 12 questions, how many of you got more than 10 correct? Okay, so good. If you got more than 10 correct, that means you understood yesterday's lesson very well. If not, see me at lunchtime. We can go over some more of these. Even today's lesson, it will tie in. All right, so on to today's lesson on page 7. All right, exponent rules, the power laws. So for the power laws, can you apply the power law to everything? No. All right, there are rules in order for you guys to apply the method. So in other words, these are like shortcuts, okay? But there are conditions. When can you use these shortcuts? You can only use the power laws in multiplication or division questions. So if it's an add or subtract, then no, you have to do it the old-fashioned evaluation way. The bases have to be the same. So for example, 3 to the power of 4 times 5 to the power of 2, you cannot combine them. Oh, yeah. Go. Oh. Yeah, in situations like this, you don't need to ask for permission. I won't say no. Okay, so you can just run to the washroom if you need to. Okay. So your base have to match, otherwise you cannot combine them. And one common mistake that people do, your base never changes. So when you apply that rule, your base just stays the same. It doesn't change. So what are the power laws? There's 3 of them, right? When you multiply, right, 3 squared times another 3 to the power of 4, in total, you can see that there are 6 3s, right? What's the shortcut here when you multiply? Shred? You add the exponents. That's right. So what about when you divide? You can cancel out, you have 10 threes on the top, 8 threes on the bottom, so you can cancel them out. And so, Grace, what do? Subtract the exponent. So 10 minus 8 gives you the 2. What if when you're raising a power to another power? So 3 squared times 3 squared times 3 squared times 3 squared. Yeah, Aiden? You multiply the exponents. Okay, a lot of time people do mix up these two because they're thinking, oh, I'm raising an exponent to exponent, so I multiply, and then, but when I multiply, I add. Okay, so keep that in mind. This is a little confusing, but that's because it's not the typical math. It's the power laws. Okay, it's the exponent rules. All right, and whenever you're in doubt, write it out in long form. So remember, this means 3 squared times 3 squared times 3 squared times 3 squared. So in total, how many are there and how many 3's are there? There's 8 of them. How do you get 8? By multiplying, not by adding. All right. If you want the full explanation, we have it right here. Okay. So let's put some of these. Let's try some of these examples. State as a single power. Okay, so 1A, Noel? 1A? 7? Let's give her a chance. Oh, sorry? Oh, okay. I was gonna say let me do it so that. Thank you, Lexi. Okay, so Noel, 1A, 4 to the power of 9 because you're adding the exponents. Okay, B, Sunny, 7 to the power of 7. Good. Kai, C. 9. What's your base? Yeah. Your base number right here, 9 squared times 9 to the 8 times 9 to the 7. So your base number is 9. Okay, and then what do we do to those exponents? So 2 plus 8 plus 7? 17. Good. All right. Thank you. Thank you, Kai and Edward. Teamwork. All right, so Edward then, can you help me with D? 5 to the 19. Good. So Felix, what about E? Okay, why? Right, that's right. It's different base. So in my morning class, somebody said 15 to the power of 8. Okay, remember, you cannot combine different base, and your base never change. So that students actually broke 2 of the rules. All right, so remember, cannot combine. So can I write it as a single power? No, but so all I could do is I could only evaluate. So read the question carefully. If it says evaluate, yes, you can have an answer. But if it says write as a single power, then you cannot. All right. So if we were to evaluate it, Felix, what would you do? All right. Here comes the calculator. 3 times 3 times 3 times 3 times 3 is
30,375.
Right. Okay. So you would actually evaluate this, and then multiply it together to get 30,375. Okay. So again, know the difference. Writing as a single power and evaluate. All right. We did not evaluate any of these. We just left these as the answer. Okay, let's do example 2. These ones right here. Where are we? Let's see. 5 to the power of 2. Should I write 25? Right, it says as a single power. Just making sure you guys were paying attention. Right, B, Vanessa? 2 to the 3. Good. Russell had a nosebleed. Maxwell. C. 2C. 8 to the 15. Good. D. Easton. 7 to the 15. And then Richard. 2E. Good. 3 to the 45. You're raising exponent to an exponent, so you're multiplying. And then last one, Sunny. Huh? Sorry. I just randomly picked. Yep, 17 to the 56. Good. Can you actually do 17 to the power of 56 on your calculator? Will it give you an answer? In scientific notation. That's right. So if you try to do this, okay, so when you do 17 times 17 times 17 times 17 56 times, your answer is not 8. Okay? That's why yesterday we learned about scientific notation. So it's actually 8.0 all that times 10 to the power of 68. So my calculator here, 2, 4, 6, 8, 9. So here's a tricky question for you guys. How many zeros is in my answer? If I were to write this out in full. Yeah.
In that, or like in 17 to the 56?
No, in this scientific notation, how many zeros? Yeah, well?
59.
59. That's right. All right, because if you move this digit over, there's 9 places. So that means 68 minus 9, 59 other digits. Okay. I like the thinking there. Okay, good. Okay, this one. Hey, keep in mind your division sign and written as a fraction, both of these mean division. And when it's dividing, it means subtracting the exponents. Okay, so for this right here, Aiden, can you help me with this one? Which one would I do first? 8. 8.
Okay. 5 to the 2.
Can you tell me the step in between?
26 plus 7. 35 minus 26 plus 7.
Yeah, so you get 5 square. Good. So with these questions, BEDMAS still applies. So you do have to do the bracket first, and then do the exponent rule inside the bracket, and then subtract. Okay. Edward H.
You divide 4 to the power of 9 by 4 to the power of 7.
Okay, I don't want to evaluate. I want to write it as a single power.
4 to the power of 2.
Good. Perfect. And then that's it. Okay, remember, you're not evaluating. You're just doing, oh, okay. I thought you had another no sweet. Okay, it scared me there. Okay, let's see, Simon?
But the first step is I first did 2 to the 14 to the power of 3, which would be 2 to the power of 42 divided by 2 to the power of 46.
Oh, so you actually multiplied it this and then multiplied it this. Okay, you could do that, but it's actually easier if you do the inside the bracket first, because then you reduces your exponent. You'll get the same answer, but yep. Oh, wait, not yet, not yet.
2 to the power of 6 times 2 to the power of 2 to the power of 4.
Good. Okay, so reduce the fraction inside, multiply, and then add. This right here always tricks people. 2 to the power of 2 cubed is not 2 to the 5, which I see all the time. Okay, typical mistake that people do. So 2 to the 6. Okay, now that I warned you guys better not have that. You guys better not make that same mistake. All right, J. Okay. Who has the answer for J? Grace. Okay, so how did you get that? I thought when the base are not the same, you can't do anything.
So the 9 becomes 3 to the squared.
Right. So 9. So don't just say, oh, can't be solved, done, next. On the quiz or on the test, especially if you see a question like this and it's out of like 3 marks, you know it's not as simple as just cannot be solved. Okay? If it's cannot be solved, it will be a 1 mark question. If you see something like this and it's like 2 marks or 3 marks, then you know it's probably a multi-step question. So in terms of format, that's how you should write it. So that 9, I can rewrite it as 3 squared. Notice I put it in brackets as well. Without the bracket, it will look like 3 to the power of 24. Okay, so make sure format as well. Okay, and then Grace, can you continue, please?
So the 3 to the power of 2, and then that time to the power of 4. So 2 times 4 is 8. So it becomes 3 to the power of 5 times 3 to the power of 8. And you add that and 3 to the power of 8.
Perfect. Good job. Right, so multi-step. So not every question is unsolvable. All right, what about K?
You can't express it single exponent, but you can simplify it. So you can factor out the 3 to the 4.
Okay.
So you get 3 to the 4, and then it's just 3 plus 1. So you can get 4 times 3 to the 4.
Okay, but is that still a single power though?
No.
No, yeah.
After that, you can just make it 343 to the 1.
Okay, so that's right. Okay, so here I cannot write it as a single power because it's adding. Remember our first rule, only when it's multiply or divide. So in other words, I can only evaluate this question. And when I evaluate it, 243 plus 81, so to give me 324. Right? Notice I highlighted these. Okay? Which means you will very likely see it on the quiz. Okay? Um, these questions are not meant to trick you. It's to make sure you know how to apply those exponent rules. Okay? All right, so that's the lesson. I am actually going to assign a little bit more. So up to page 15. Okay, you have plenty of time. You have like 50 minutes. You have 50 minutes of time to try to do all the questions. My morning class finished up to page 13 during class, so it's actually pretty fast. Some of them, remember, you have to change the base. Okay, so up to page 15.